In this video, we're going to talk about how we can write a quadratic equation when we are given the vertex and another point. So before we complete an actual example, let's think about this a little bit. If we're given the vertex, we know that we're able to at least get a good start on one of our three forms of the quadratic equation. So we have standard form, we have vertex form, and we have intercept form. And hopefully you are already thinking that, well, vertex form makes the most sense because it uses the vertex. So we have to keep that in mind. So our vertex form is y equals a, and then we have x and the opposite of h squared plus k. We can include our b value here, but for the problems we're going to tackle, we aren't going to include b. So here we know that in vertex form, if we have the vertex, we can fill in h and k. So if we can fill in those two values and the only thing we have left to find is a, we should be able to tackle that by using this additional point. So when we have a vertex, we are always going to write our equation into vertex form. So let's dive in and try an example. So here it says write an equation given a vertex and an additional point. So because we're given a vertex, we're going to focus on vertex form, which is y equals a, then in parentheses, x and the opposite of h squared plus our k value on the outside. So I know that I need to find a, h, and k in order to write an equation in vertex form. Well, what's really nice is right off the bat, my vertex gives me h and k. So here I have y equals my a value I don't know yet, but I have x and the opposite of 5, which is negative 5 squared, plus the 6 for k on the outside. So I've already found h and k here. And my last step is to find my a value. And how we're going to do that is we're going to utilize this additional point here. So this additional point here needs to work in this equation. So this is an xy point that is going to work in there. And what we're going to do is we're going to substitute the 3 in for the x and the 14 in for the y. And in doing so, we're going to have a situation where we can actually find our value for a. So 3, 14, the point, has to work in this equation for that xy combination. So we have to find the a value that makes this true. So if we write this out, we get 14 equals my a value. Then I have 3 minus 5 squared plus 6. So now all I need to do here is rewrite this for a, and I need to follow my order of operations in order to do so. So we're going to start with parentheses. So I have 14 equals a times negative 2 squared plus 6. I then evaluate my exponent, which is negative 2 times negative 2, which we should all know is 4. So I'm going to write this as 14 equals, I'm going to move the 4 to the front of the a, so I have 4 times a plus 6. Then from here, I need to solve this equation, so I subtract 6 from each side. So I have 8 equals 4a, divide both sides by 4, and I find that my a value is equal to 2. So now I have the a, h, and k values that I need in order to write my equation for this particular quadratic function. So here I'm going to go back to vertex form and I'm going to write y equals, my a value is 2, parentheses x minus my h value of 5 squared plus k on the outside is 6. So there I have the equation that contains this vertex point but also goes through the point 3, 14. So let's try one more example here. Again, we're given a vertex, so we're going to write our equation in vertex form. So we're going to need our a value, our h value, and our k value. So we can start off by saying we already know h and k because h and k are contained in our vertex. So we have y equals a, then we have x. This is really going to be minus a negative 3 because it's the opposite of negative 3, so that's going to be a plus 3 squared. And then we have plus negative 4 or minus 4 on the outside. So here we at least have found h and k. So our last step here is we need to focus on finding a. And we're going to find this a value by substituting this point that needs to work in our quadratic function into that equation. So we're going to have a y value equal to negative 12 and an x value equal to negative 7. So I have negative 12 is equal to my a value. I then have negative 7 plus 3 quantity squared, and that's minus 4 on the outside. So then I start with my order of operations, so parentheses come first. So I have negative 12 equals a, negative 4 squared minus 4. Well, I then need to evaluate my exponent, which is negative 4 squared. Negative 4 times negative 4 gives me 16, so I'm going to write this as 16a. Then there's the minus 4 on the outside. Then I need to solve for a, so I add 4 to each side. Negative 8 is equal to 16a. Divide both sides by 16, and I get an a value that's equal to negative 8 over 16, which simplifies to negative 1 over 2. So I can take my a value now, and I can substitute it into my vertex form equation. So I end with a vertex form of y equals negative 1/2 for a, x plus 3 for the opposite of h squared, minus 4 on the outside.